Okay, we want our Be a Scientist notebooks out, and we're going to be open to page 28. On page 28, we're not going to worry about the top question, but if we look down below, they want us to read our science handbook. We're going to go kind of fast through this, so I'm going to read it to you, and we're going to answer the following questions after we finish reading. So the first question, everybody point to it, says number 8. It's the first question though, and it says, describe the forces in balanced force. So describe the forces in balanced forces. We're going to read about it. And then the next one says, what forces cause a change in motion? So we're going to read about balanced and unbalanced forces and fill out those 2 questions today and then move on. Sound good? So as I'm reading, think about the forces in a balanced force and think about what forces cause a change. Okay? Sound good? Well, we are about to read to find out more about this fabulous picture.
It's not fun. Shoot. I think dogs
Okay.
are on the force. Not really. Yeah. Not on the
Okay, we're going to go ahead and read. Sound good? Types of forces, and we're going to start with balanced forces today. I'm reading, you're listening for the answer of our 2 questions today. And we will get to our picture of our puppies at the bottom, and we're going to talk about it. When a batter hits a baseball, he or she applies a force. Other forces, such as gravity, are at work too. How do all the forces acting on an object affect its motion? When you put a heavy backpack on your desk, the backpack does not move. Gravity pulls the backpack towards Earth, but your desk is in the way. The desk pushes up on the backpack with a force. The strength of that force is exactly equal to the pull of gravity. The forces are
equal.
Balanced or equal. Balanced forces are forces that cancel each other out, or balanced forces are forces that cancel each other out when acting together on an object. So balanced forces cancel each other out. I might be pushing really hard, but if Griffin's really pushing hard too, is the object going to move?
No.
No, because it's balanced. Those forces are canceling each other out. The forces are equal in size and opposite in direction. So I could be pulling it really hard and he could be pushing it really hard. Is it going to move if I'm pulling it and he's pushing it? Because we're trying to go in the same direction. But if we're both pushing and we're facing each other, are Griffin and I going to be able to move it? No, because those forces are opposite. If we're going the same way, we'll move it. If we're going opposite of each other, we're not going to be able to move it. When an object is sitting still, all of the forces acting on it are balanced. So we do see these cute little puppies down below. It says, if the puppies pull in opposite directions with equal force, the shoe does not move. The forces are balanced. So how many of you have an animal that you play tug of war with at home? If you're playing with it and you're pulling at it and you can't get it away from the dog, those forces are what?
Balanced.
They're pulling and you're pulling. And if you can't get it away, it's balanced. The minute you rip it away from them, it's no longer balanced because you're stronger and they're not acting on that anymore. Okay? So our first question on there is describe the forces in balanced forces. So if something's balanced, what do we know about those forces that are acting? Brock. They're going to be the same, but they're going to be equal in force, but the forces have to be what? The same direction or opposite directions, right? So we know the balanced forces cancel each other out when they're acting together on an object. The forces are equal in size and opposite in direction. Sorry. The forces are equal in size and opposite in direction. What do we know about balanced forces? They are
Equal in size and opposite in direction.
Fabulous. Go ahead and make sure you have that written down today for our first question. So we'll move on and read about those unbalanced forces. Unbalanced forces. Suppose that you push that heavy backpack across your desk. So you got that backpack. Before it wasn't moving because the desk's force were pushing on it. Gravity was pushing down. It just didn't move. Now you're taking that backpack and you're pushing it across the desk. There is friction between the backpack and the desk. Remember, friction is when two objects rub on each other, right? The force of friction is weaker than your push. So your desk is pretty smooth, right? So is it pretty easy just to push your backpack? That means that force of friction isn't very much. You're stronger than the friction is. How can you tell? We can tell because the backpack's gonna what? It's gonna move, right? Everybody just take your book even in front of you and move it a little bit. There's friction going on, but can you move your notebook across your desk? Yeah. I know they're not very heavy, but it's pretty easy because the friction's very little and you're stronger than the friction. We'll go ahead and pause with that one. Forces that are not equal to each other are called unbalanced forces. So if they're not equal, they are
Unbalanced forces.
If there are two opposite forces acting on an object, then the greater force determines the direction of the motion. So if they're going opposite, again, if my dog and I are playing tug of war and no one's winning, we're just kind of go like sitting still with it, that's balanced. But the minute one of us decides to get stronger and takes it from the other, is it balanced anymore?
No.
No, the greater force has went out and it's unbalanced. If I'm finally able to get that chew toy from my dog, it is no longer balanced and I've won it. Then I'm going to apply a force when I throw it as well. Right.
So it's just like that, but with the socks. Ruby will take one of my dad's socks out of his walk-in closet, and then I'll have to like grab onto the end and I'll catch her. And then once I get like right here, like she'll just start tugging even harder.
Yep, because she thinks you're playing. So
Yeah.
it's still that those forces in act, right? Let's see. Look at the dog sled shown in the photograph. The force of the dogs on the dog sled is greater than the force of friction on the dog sled. So there's friction. This sled is sitting on snow, right?
Mm-hmm.
Especially depending on where that snow is, there could be a lot of friction or a little friction. But the force of these dogs pulling it is stronger. When they work together, they're able to pull it, and they're stronger than that friction. Let's see. So the dog sled moves. Unbalanced forces can affect an object's direction. Unbalanced forces can affect an object's direction, speed, or both. The sled now goes in the direction that the dogs run. The faster the dogs run, the greater the speed of the sled. Make a little sense? Perfect. So, which forces can cause a change in motion? Unbalanced forces. Pretty simple, right? Balanced forces. Is there going to be a change in motion? As soon as it's unbalanced, will we see a change in motion?
Yes.
So number 9 on that page, which force causes a change in motion?
Unbalanced forces.
Fabulous. Go ahead and get it written.